Very good morning, one and all. Myself, D.Jyothi, Assistant Professor, Department of CSC Data Science, MLR Institute of Technology, Hyderabad. Today, we are going to cover how to generate the random variables, how to do the Z-score calculations, t-test calculations, logistic regression, linear regression, and the clustering in this upcoming lecture. So, these are the overview of the topics we are going to generate today. We are going to discuss today: generating random numbers, summarizing the data, calculating relative frequencies, contingency tables, chi-square test, quartile values, Z-score, t-test, testing sample proportions in R, testing normality in R, testing mean of two samples, testing correlation for significance, linear regression, logistic regression, and clustering topics we are going to discuss today. Generating the random numbers. For generating the random numbers, sample function is used. Look at here, we are having the sequence 1:10, and we are generating the in that 1 to 10 we are generating the two random numbers. Here 4 and 6 numbers are generated. So look at here, same code I'll run for 2 times. As the sample function generate random numbers, whenever you execute this function number of times, number of different random numbers will be created in a range of 1 to 10. So when I for this one, the first run I have got 9 and 5 values. For the second run I have got 9 and 1 values. So if you want the same values to be displayed every time I run a sample function, then I need to set the seed. Here I am using set.seed 314, and here again I am running the sample function. I have got 3 and 4 as the random values. I have run this function again and again. I have got the same values 3 and 4. So you want the random number generating function to generate the same numbers at every execution, then you have to set the seed. So for the normal distribution, you want to generate the numbers according to the normal distribution. R norm function, built-in function is used. You want to have the quartile of distribution, Q norm function, built-in function used. Density function, D norm function is used. Cumulative distribution function, the P norm function is used. So these built-in functions by default, they will be generating the data for us. Summarizing the data. In summarizing the data, we will be applying the summary function to different data types available in the R programming language. Here I have a vector. In that I have the values 1, 2, 3, 4, 5, and I am applying the summary function to a vector. So what are the observe the output. At the output, it will generate the parameters 1, 2, 3, 4, 5, 6 parameters. So first parameter is the minimum value in that vector, first quartile value in the vector, median in that vector, mean in that vector, third quartile value in the vector, maximum in the vector. These 6 parameters will be generated by when we apply this summary function to a numeric data. So whenever we apply the summary function to the factor, so when we apply this to a factor, it will be displaying the levels of the data. So here I have apple, banana, apple, orange, banana, and apple. So how the levels are created is the most repeated value will be the level 1. Next most repeated value will be the level 2. Like that the levels will be created. Look at the output. Apple is repeated for 3 times, banana is repeated for 2 times, orange is repeated for 1 time. So when we apply summary function to the factor, it will be giving us the different output. It displays the how many levels, number of levels are there. Next one, summarizing the character vector. So this is the vector I have. the character vector. I am applying a summary function to the character vector. The parameters it will display are only the three parameters it will display. The length of the vector it will display. Length of the vector is 1, 2, 3, 4, 5, 6. The length is 6. What class of data it is? The class of data is the character class. So what mode of data it is? Mode of the data is also character in this case. So here, look at here, summarizing a logical vector. So when you apply summary function to the logical data, this is the logical data. I have true and false, and NA is also there. So it will be displaying in this format. It will be displayed in the levels. The mode is the logical, and how many number of false are there? 2. How many number of trues are there? 3. How many number of NAs are there? 1. Next one is when we summarize the complex data. So we'll be getting the output like this: length, class, and mode. So we have the length, 3 numbers of complex data we have. The class type is the complex type, and the mode type is also the complex type. So we can apply the summary function to the dates as well. So we have the dates defined here. Same 6 values it will display. The minimum value, first quartile value, median, mean, third quartile value, and the maximum value. That means the minimum date, first quartile date, median date, mean date, third quartile date, and the maximum date will be displayed. Calculating the relative frequencies. For these, we are taking the synthetic data. So look at the data. We have A, B, AC, BA, CC, B, and A. And I am declaring these data as a factor because it is a categorical data, and I am applying it to the category. So look at here in the category, it will display. It will display the categorical data. When you try to display the data frame, we have created a data frame and we have displayed the data frame here. For calculating the relative frequency, we have to calculate the absolute frequency. So for calculating the absolute frequency, we are using the table built-in function. The table built-in function is applied to the category. So when you, how many number of A's are there here? 1, 2, 3, and 4. 4 number of A's are there. How many number of B's? 1, 2, 3. 3 number of B's are there. 1, 2, and 3. 3 number of C's are there. When you apply the table function to the data, it will generate the cross tabulation of the data. So it will display how many number of A's are there? 4. How many number of B's are there? 3. How many number of C's are there? 3. And here for calculating the relative frequency, we have a formula: absolute frequency by number of rows of a data frame, and we are printing the relative frequency data frame here. So the values we have got are like 0.4, 0.3, and 0.3. These are the relative frequencies of A, B, and C. Next topic we are going to discuss is contingency table. Contingency table with 2 factors. So in the previous example, we have only 1 factor. In this, we are going to have the 2 factors. The factor we have on a gender data, and we have the factor on the preferences. So look at here: male, female, female, male, male and female, AA, BB, and AB. We are just printing the data here. In the contingency table, we are applying the table built-in function to the gender and the preferences. So here gender will come and here the preferences will come. Look at here, how many female are A? How many female are A? 1. Only 1 is there. How many female are there? Female A. How many female A are there? 1. How many female B are there? How many female B? 2. How many female B are there? 2. Like this, when we are having the two factors, on the two factors you apply a table built-in function, it will cross tabulate the data. How many female A's are there? 1. How many female B's are there? 2. How many male A's are there? 2. How many male B's are there? 1. This is a contingency table generated for the two-factor data. Next topic we are going to discuss is the chi-square test. It is a very important, very much used in the real time examples. Here the same example we have taken gender and preferences data. The same data also we have taken here. So we are printing the data here. That is the first step. So we have created a data frame and we are printing the data frame here. And here again we are cross tabulating the data. So on two factors we are cross tabulating the data. As we have taken the same example, how many female numbers are there? 2. How many female B's are there? 3. How many male A's are there? 3. How many male B's are there? 2. On this we have a built-in function that we can apply directly to the contingency table. Only to the contingency table you have to apply the chi-square test. We are applying the chi-square test to the contingency table and we will get the output. The p-value we have got here is 1. The df value we have got here is 1. Chi-square value we have got here is 0. The terminology we are going to use in the coming examples are null hypothesis, that is H0. Assume no effect and no difference between the group. What is an alternate hypothesis is H1. Assume there is an effect or a difference between the groups. And test statistics, the value calculated from same data used to compare against a distribution to determine the significance level. Degree of freedom, that is in the output it will display it as a DF. The number of independent values in the data that can carry depending on the sample size. The very important value is the p-value. The probability of observing the test statistics are something more extreme. Assuming H0 is true, a small p-value, typically less than equal to 0.05, indicates strong evidence against a H0. What is H0? Is null hypothesis. The threshold, very simple, the p-value we take, the threshold value is 0.05. So if it is above the threshold value, then if it is above the threshold value and the value is more extreme, so it will go into the null hypothesis. If the value is somehow near to this one, then we can tune the parameters. If it is less than this one, so the less than this one, then also there is a possibility sometimes we will reject the hypothesis. Calculating the quartiles. So we have the data vector here, the values are 1 to 10 and we are printing the data here, observe the data here, and we have a vector 0.25, 0.50 and 0.75, and for these calculating the quartiles we have a built-in function that is quartile, and we are applying that quartile to the data. What is the data? This is the data we have, and the probability value we are defining, that is the F vector. In the F vector we have defined a probability value. So what is the F value here? For 25%, for 50% and for 75% we are calculating the quantiles. And here look at the output here. For the 25% we have got 3.25, for the 50% we have got 5.50, for the 75% we have got 7.75. The next topic is calculating the Z score. Here we have the vector. In the vector we have the values from 1 to 10 and we are printing the data here. Observe the data, and we are calculating the mean of the data by using a mean built-in function, and we are calculating the standard deviation of the data by using a SD built-in function, and we are printing the mean of the data here. The mean of the data is 5.5, and we are printing the standard deviation of the data, that is 3.0. Now for calculating the Z-score, so we are using a formula here. Z-score is mean of the data by standard deviation of the data, and we are printing the Z-score here. Observe the values here. We have printed the Z-score. This is the normal manual way of calculating the Z-score. Instead of this, we have a second method. The second method is also applied on the same data of the previous example. We have a vector, it is moving from 1 to 10, and we are applying, instead of calculating a mean and standard deviation, we are applying a scale function here. Scale function is applied on the data, and we are printing the Z-score directly here. So observe the values. So these are the Z-scores we have got. Next topic is the t-test. For calculating the t-test, we are taking the two vectors. So group 1 and the group 2 vector, and in the group 1 I have the values 5, 7, 8, 6, 9, and group 2 I have the values 10, 11, 12, 14 and 13. And here I have a built-in function for calculating the t-test, that is t.test. I am applying these on the group 1 data and the group 2 data, and I am printing the t-test here. So these are the estimated values I have got after executing the program. The t value I have got is -5, df value is 8, p value is 0.001053, where what is the threshold value of p, that is 0.05. And here alternate hypothesis, 2 difference in mean is not equal to 0, 95% confidence interval. The values are confidence interval values are displayed here. Mean of x and mean of y, 7 and 12 values are displayed. Depending on the p value, we will decide the hypothesis. Look at the conclusion. As the p value we have got is 0.001053 is less than the common significance level 0.05, that is the threshold value of p, and we reject the null hypothesis and conclude that there is a significant difference in the mean of two groups. So these t-tests can be applied to a very small examples, to a very big real-time examples that impact our lives. Testing sample propositions in R. So look at the examples. In a city A, 60 out of 150 people prefer electric cars. In city B, 80 out of 200 people prefer electric cars. So for these, we need to apply the proposition, and we have to derive the p value out of it. And the success is 60 here in a vectors 60 comma 80, the success rate, and trial rate we are taking 150 and 200. For applying the propositions, we have a built-in function proposition.test, and here I am using the two vectors, successes vector and the trial vector, and I am printing the output here. So here I have got the p value as 0.55. So df value I have got it as 1. Chi-square value I have got it 0.3505. And look at the output. Since the p value is the threshold value is 0.5537 is greater than the common significant level of 0.05. So we fail to reject the null hypothesis. This means there is no significant difference in the proportion of people. People prefer electric cars between city A and city B. Depending on the p value, we are going to decide whether it is going to a null hypothesis, or whether we are justifying the hypothesis or not. Testing. The next topic is testing normality in R programming. For these, we need a little more data points. So we are generating the data points by using the R norm function, and we are setting the C to 123 here. And by using the R norm function, we are generating the data points where the mean I am defining it as 100, SD I am taking it as 15, and I am applying a Shapiro.test built-in function here. So we have the different, so many functions available, but in this example, Shapiro.test has been taken. That test is applied on the sample data, that is randomly generated by random data points generated by the system. And here I am printing the results here. These W indicate that whatever the test we are applying, that means Shapiro milk normality test, the author name, with the author name, W will be taken as a parameter here. W value we have got is 0.98928, and the P value we have got is 0.9279 in this case. And to test how the data points are spread, so we are using the quantile plot. By using the quantile plot, we are we are assigning the sample data to the QQ norm, and the line we are we have assigned the red color to the QQ line data. Look at this one. These are the data points here. These are the data points, how the data points are aligned to the normality. This is the normality level we have assumed, but data points are sometimes are near to the red line. Here, W value I have got it as 0.98589, and the P value I have got is 0.8159. In the conclusion, since the p-value is 0.8154 is greater than the common significance level of 0.05, so we fail to reject the null hypothesis. This means there is no significance evidence against the assumption that the data is normally distributed. Testing the mean of two samples. So we have the sample 1, group 1 data we have 5, 7, 8, 6, 9, and the group 2 data we have 10, 11, 12, 14 and 13. And the t-test results, we are applying a t-test on group 1 data, group 1 and group 2, and we are printing the results here. So the parameters are displayed are like t is for the t-test statistics value, that is minus 6.036, and the degree of freedom I have got is 7.987, and the p value I have got is 0.000365, and the alternate hypothesis is equal to 0. The confidence interval I have the value from the range minus 7.7, 161712 to 3.883829. Sample estimates are group 1 sample estimate is 7.0 and for the group 2 12.0. And look at the conclusion, as the p-value is 0.000365 is less than the common significance level of 0.05, we reject the null hypothesis and conclude there is a significant difference in the mean of two groups. Testing correlation for significance, here we have the height vector and the weight vector. The correlation for calculating the correlation test, we have a built-in function called cor.test function. So here the parameters you are sending as height and weight parameters, and we are printing the output here. Here the t value I have got is 17, df value is 3, the p value I have got is 0.0004433. Based on this, I have got the correlation value of 0.9848498. And the conclusion, the p-value is 0.000443 is less than the common significance level of 0.05. We reject the null hypothesis and conclude there is a significant correlation between the height and the weight. Next topic we are going to discuss is the linear regression. Here I am taking the study hour data, vector data, and the exam scores data I am taking here. And I am creating a data frame for the study hour and the exam scores data, and that I am applying it to the data variable. For the linear regression, I have a built-in function called LM. In that, I am applying that LM to the study hours data and the exam scores data. I am printing the summary. So minimum value, first quartile value, third quartile value, maximum value, the coefficients are displayed here. The p-value I have got is this one. Adjusted R values I have got like this. And F statistics, these are the F statistics I have got. The significance scores I have got. The estimated standard deviation, error, t value, and the probability value. Next one, the logistic regression. When we have the categorical data, so we have to go for the logistic regression, where the linear regression won't work when we have the categorical data. And the same here, I have that as well as the logistic regression. When you have the binary data as well as the categorical data, then we have to go for the logistic regression, as the linear regression won't work there. So here I have the study hour data and the pass and fail data, and GLM is the function, built-in function used for logistic regression. And here I am applying it to the study hours and I am applying into the data I have created. And GLM is for logistic regression, and the binomial family, the family I am applying, the probability family I am applying is the binomial family. And I am displaying the summary logistic model. Look at here. So I have got the estimated value, standard deviation, error, Z values, and the probability values, and number of iterations as 25. Next topic we are going to discuss is the clustering. In this clustering, for the visualization, if we have the more data points, we get the proper visualization. So we are setting the seed into 123, and we are generating the random numbers of 100 and 100 with mean 50 and the standard deviation 10, and we are that are assigned to the income variable, and I am generating 100 data points with mean 50 and the standard deviation 15. I am applying it to the spending score, and I am loading this entire data into the MAL data, that income and spending score. I am assigning into the MAL data, where I am setting the clustering into 3 here, and here the k-mean algorithm I am applying, and here how many center points I needed is 3 center points, that k I have defined here. The n start is 20, and I am printing the k-mean model. I am using visualization to get a view on how the data points are allocated. So look at the visualization here. So I have assigned 3 data points. The data points are clustered into 3 centroids. So look at the color coding. So these observe the color coding here. So how the data points are spread in this clustering. Thank you, one and all.